Welcome back to Chemistry Exams Prep. This is Dr. Kulbhushan. I am back with another interesting question for you. This question was asked in IIT Joint Entrance Exam in 2021. In this question, we need to figure out the order of reactivity of the following 4 carbanions. So a carbanion is a species that has a negative charge on a carbon atom. So to answer this question, we need to see the stability of these 4 carbanions, and then we need to apply the principle that the reactivities are generally inversely proportional to the stabilities of these charged species. So to solve this question, we need to apply 3 principles here. The first one is the hybridization. Second one is the resonance effect. And the third is inductive effect. About hybridization, we know that if the hybridization is sp, then the carbon that contains the negative charge will be most stable. And if the hybridization is sp2, that would be more stable than sp3 hybridized carbanion. So in these cases, we don't have any sp hybridized carbanion, but we do have sp2 hybridized and sp3 hybridized carbanions. So carbanion A is alkyl carbanion, and this has sp3 hybridized carbon that has the negative charge. So there is no possibility of resonance stabilization, and also the next carbon is also sp3 hybridized, so that would be the least stable, hence more reactive, the most reactive species. Now the carbanion B is phenylcarbanion. It has sp2 hybridized carbon that has the negative charge. C is allyl carbanion. Also this carbon is sp2 hybridized. Now the question is, why some carbanions are sp2 hybridized while the others are sp3 hybridized? So when the carbon that bears the negative charge is next to an sp2 hybridized carbon or sp2 hybridized heteroatom like oxygen, sulfur, nitrogen, then the carbon gets the sp2 hybridization configuration so that there would be p orbitals that can help in resonance stabilization of the negative charge or the positive charge in case of carbocations or free radicals. So let's draw the orbitals for phenylcarbanion and see where the negative charge is. Is there a possibility of resonance stabilization in B, C, and D? So since carbon C is sp2 hybridized, the negative charge resides in one of the sp2 hybridized orbital. So this negative charge cannot be delocalized. There is resonance because this is an aromatic species. So there is resonance, but this negative charge is not being stabilized by resonance. And the same case is with the vinyl carbanion. There is also no stabilization by resonance. So the negative charge stays in one of the sp2 hybridized orbital. However, in case of allyl carbanion, there is resonance stabilization. And the reason for that is because the negative charge is in p orbital, so it can take part in resonance, and you can draw the resonance structure. So another resonance form would be this one, and you can draw a resonance hybrid where the negative charge disperses, so the end carbons get partial negative charge, and this resonance stabilization makes this carbanion most stable out of these 4 species. So that's C is now most stable, A is least stable. Now we can remove some choices. So the most stable would be the least reactive here. So it means that the option that do not have C in the end are not the correct choices. So here you can eliminate A. You can also eliminate choice B. Now between B and D, we need to see the reactivity or stability of species B and D. So out of vinyl and phenyl, which species would be more stable? So it seems that if you see the pKa tables given by Evans, then you will see that phenyl carbanion is more stable conjugate base of benzene acid. Therefore, the phenyl carbanion is more stable. Hence, the answer would be D, not the B, because the vinyl is more reactive, and that's why the order of reactivity now becomes A is most reactive, then D vinyl, then B, that is our phenyl, and finally C, which is allyl carbanion. So to recap the question and the concepts that we have applied, for the carbanions, the species that contain a negative charge on a carbon atom, they can be sp2 hybridized or sp3 hybridized, and sp2 hybridized carbanions are more stable than sp3 hybridized carbanions. In resonance, if there is a minus resonance effect like in the allylic one here, they would be more stable than the ones where there is no possibility of resonance stabilization. Also, minus inductive effect also helps, and this species B here is the example, because here the negative charge is next to 2sp2 hybridized carbon, and that's possibly one reason why phenyl carbanion is more stable than the vinyl carbanion. That's the end for this question. If you have any concerns or questions, please let me know. Thanks for watching.